पर ये देखिए रिप्लाई आप आ गई मेरे ख्याल से तो आ गया जी नदीम साहब आप बात करें आप कुछ कहना चाहते हैं मैंने मतलब शुरू करना है प्रोग्राम आपका हैंड रेज हुआ है या हैंड नीचे कर लें अगर कोई बात नहीं है तो आपका हैंड रेज हुआ है उसको आप
सॉरी मुझे पता नहीं था मुझसे गलती से हाथ लग गया था सॉरी सर अब ठीक हो गया
जी
राइट ओके ओके मैं म्यूट कर
चलें जी इट इज 10:02 हम इंशाल्लाह इसको आप स्टार्ट कर रहे हैं जी खुर्रम ठीक है आर यू रेडी जी ठीक है आई एम गोइंग टू स्टार्ट इट फॉर्मली नाउ
Sure, I'm ready. Good to go.
Bismillahirrahmanirrahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum and good afternoon from Lahore, Pakistan. A very warm welcome to all our participants who have joined us on Facebook. This is technical lecture number 59 of Pakistan Society of Civil Engineers. Those who have joined us first time, it is just for their information that PSCE holds one technical lecture every month, and by attending this lecture, you can earn half CPD point, which is recognized by Pakistan Engineering Council. Now, before I introduce the speaker to you and the topic, it's my duty to read out the rules of this webinar as per instructions given by Pakistan Engineering Council. The first one is all registered participants for CPD points must appear live on their webcam, but for the ladies, there is a choice. If they wish, they can cover their face, but in any case, they have to appear live on the webcam. During the lecture, microphone of all the participants, except that of speaker, shall remain in mute position. There will be a question answer session at the end of the lecture of 20 minutes duration, during which you can type the questions and I will read out the questions to the speaker for his answer. You can also write the questions during the lecture and I will keep on noting them. Participants on the Facebook can also type their questions in the chat box, and we have a separate staff member who keeps a check there who is typing the questions and which questions are being typed. So these were the rules of the webinar. Now, the topic, today's topic is digitalization of an engineering, design, modular, and off-site construction of a built environment project. And today's our speaker is young, dynamic Khurram Tahir. He is based in Australia. He is delivering this lecture from there. So a very short introduction of Tahir Saab. He is a chartered mechanical and building services engineer with over 18 years experience in the field of building services engineering projects in Australia, Middle East, Pakistan, Sri Lanka, and Indonesia. Tahir started his professional career right from the basics of engineering with concept development, plant and equipment sizing, detail designing, and specifications. Throughout his career, Tahir has engineered and project managed construction projects over a range of sectors, including commercial buildings, stadium, healthcare facilities, data centers, educational institutes, residential and hotel apartments, and urban precinct developments. Tahir has had an extensive experience in high technology facilities locally and internationally, and he understands the needs of complex building services. So a very short introduction of Tahir Saab. Now, inshallah, Tahir, you can start your lecture. The floor is yours. And before I allow you to say, I will just remind my audience that please do not force me to make the announcement for switching on your webcam. This is instruction of Pakistan Engineering Council. We cannot give you any relaxation on it. You have to appear live. Only those who have applied for the CPD points. Thank you, Tahir. Go ahead, please.
Thank you so much, Tahir Sultan Sahab, and Assalamu alaikum to all the participants. Tahir Sultan Sahab, thanks for introducing me about my background and what I have been doing. Okay, so let me share the screen, and then Tahir Sahab, could you please confirm when you can see the screen, and after that I'm gonna start.
Your screen has changed, but the slide has not appeared yet. So we just, yes, it's okay. Go ahead. Please go ahead.
Great. Thank you. Just bear with me. I'm just doing my screen setting so that it doesn't disturb me later during the presentation. Great. Okay, so I'm assuming everybody can see my screen. First of all, I would like to say thank you to Pakistan Society of Civil Engineers for giving me this opportunity to present a CPD lecture in terms of digitalization of an engineering design, modular and off-site construction of a built environment project. When Pakistan Society of Civil Engineers, they contacted me, I was thinking about a different topic. And my topic was ranging in terms of a basic MEP system design for a tall building. And also I have also thought about the fire engineering side of the thing, because that's what I thought the industry in Pakistan, they would need some support in terms of how the first world countries engineering practices are being done. But then when I was about to press a send button in terms of the topic selection, I thought about why don't I come up with something which is not being currently fully practiced in Pakistan. We do understand there are a lot of individuals they are practicing, and in fact the organization they are practicing, but still I see there's a huge gap in terms of where the world is heading for the engineering design and also the construction practices, especially for the built environment project. So the name appears pretty long, and the reason for this long name is I'm going to cover a lot of topics in this short session, roughly 1 hour and 30 minutes, I see. But the whole point is not to make everybody full on engineer in terms of what exactly is happening. It's all about giving a glimpses of what we can do moving forward and the way the world is heading, and where we can see or identify the gaps and what this means for Pakistani market and also especially for the Pakistani professional. So my topic is not going to be a very hardcore sort of a civil engineering topic. It's more of a like telling or advising what are the values or what are the options available to work different aspect of a engineering design for a project. So if you see on the screen, I have underlined some of the key item of the presentation. One is called digitalization, and digitalization is connecting with the virtual construction. Then there is a modular and off-site construction, which is picking up a lot of attention in the first world countries and also in the Middle Eastern market, and built environment. And built environment, as we are all aware, is what is the definition of a built environment? Environment which is created by us as a human. So there's a lot of complexity goes into it. So if you just bundle everything out, the term which comes up is called the visual construction, where we design literally everything and we model literally everything before it goes into the construction. So if you can see on the screen, there's a project which is happening on the left-hand side. I have shared the screen of that, and the virtual construction of the project is done by using different mechanism or tools available these days in the world. And then before we press the plug for construction, we can look into all the aspect of the engineering design side of the thing. Okay. Here I would like to also acknowledge one item is like the pictures, the references, the project's picture. What I'm going to show into this presentation is personally myself, I got involved into those projects, full-time, part-time, sometime in hybrid resources. or my current organization where currently I'm working or leading, they've been involved into it. Okay, there are certain research references which I'm going to utilize during the presentation. All the references and annotates are being written up there, but there are certain web-based images which I have taken because due to the confidentiality and non-confidentiality agreement we have signed with some of the clients, we are unable to show some of the images, and that's where we have considered some of the generic references. So I'm going to go ahead with this presentation now. So it's all about gonna be the virtual construction and how things get done in terms of engineering design and offsite modeling and offsite construction of a built environment project. Okay. So quick introduction already been given. I'm Khurram Tahir. I'm one of the managing director of Hydrogen. Hydrogen is an engineering organization, and I'm a chartered professional engineer for mechanical and building services engineering. And I'm also a registered building practitioner, national engineer registered, and also data centers Uptime Institute accredited tier designer, which is given by Uptime Institute, Singapore, and in fact across the world. I think their head office in the US. Green Star accredited professional, APAC engineer, international professional engineer from Engineer Australia, and registered building practitioner. By the way, recently I also got to become a professional engineer for Pakistan. So apologies, I didn't update it into that. Okay. Introduction. What is BIM? Most of you have heard of it. It's kind of like a buzzword these days, also in Pakistani industry, but as well as in the world. So BIM is all about is a collaborative process that involves creating and managing digital representation of physical and functional characteristic of a built asset, providing stakeholder with a centralized information, 3D visualization, data integration, and life cycle management capability. BIM is how I can say is like BIM is a kind of like a generic field. We use different type of tools to achieve the BIM processes. Okay, but overall, BIM is an overarching phenomena which advise how to create and manage digital representation of physical and functional characteristics of a built asset. There's another word which is coming these days, which is the digital twin, which is a virtual replica of a physical building or urban environment. And in digital twin, what happened is like what we design in BIM, we then operate that building, we capture all the data, and then we compare those data via the digital twin processes to see what values were there during the design side of the things and what is currently under operational. So if I want to compare what is a difference between digital twin versus BIM, BIM focuses on creating a comprehensive 3D model of a building or infrastructure project, whereas digital twin extend beyond the initial design and construction phases by incorporating real-time data and enabling ongoing monitoring and analysis. Take an example, if we design a high-rise building, there are certain design parameters which we consider in the designing of the building that covers under BIM. But when that building is operational, we collect real-time data and then we conduct ongoing monitoring and analysis. Okay, so in summary, BIM is primarily used during the design and construction phase, whereas digital twins are utilized during the operation and maintenance phase to enhance performance, efficiency, and decision making. And then when the word called offsite or modular construction, and then we use a term called modularization. And modularization is method that deals with the configuration of product or system by identified component that can be grouped together so that they can operate independently to fulfill certain requirement in a larger operation. So under modularization, what we consider is like what modules or certain part of the system of a built environment project we can configure in that way, or we can group in that way that we can do an off-site construction. Instead of constructing at site, we can do off-site construction. We bring the component via a transport or logistic mechanism, such as like 20 feet container or 40 feet container, bring on site, lift it via the cranes, okay, put it into the plant room, connect with the system and move on. In terms of the civil engineering side of the thing, it's more of a like a precast panel. But in terms of for the precast panel, all the penetration in the precast wall or in the slab, or even in the steel structure, or even nowadays in Australia, the wooden structural element, they're getting very popular. All the coordination will be done offsite. They will get modelized, they will come on site, and they will get connected with the system. Okay, I'm getting some background noise. Somebody is unmute. Okay, over to Tahir. Tahir, just make sure everybody's muted because I'm getting some background noises. Okay. And what is a built environment? Built environment is a structure which is a man-made structure, which is being. Sanya, if you don't mind, can you just mute yourself, please? Thank you. So what is a built environment? Built environment is a man-made structure where in a single construction, there are different operational happen within the building. Okay, so I'm giving one of the examples. This is one of the projects that we have done in the past, where you can see that the total cover area of the building is pretty good, which is a common podium. And then there are 3 towers arising from that common podium. So from a civil and structural point of view, when we see the building, they represent different values to the engineers. But when we started looking into seeing the building in terms of architectural element as well as the MEP side of the things, we see different operational use as a different entity. Take an example of hotel rooms. They have a different requirement as compared to the residences, okay? And the lobby area, retail area, and the restaurant, they have a total different requirement in terms of the operation side of the thing, with regards to the pool, spa, and the outdoor area. Office, they present a different operational requirement from a system design point of view, whereas the entertainment area is a total different requirement, okay? And the car park area has a total different requirement and the code requirement side of the things. So when we start putting all this thing into the built environment, we come up and name that thing as a project. Like, this is a project what we are doing. And the benefit of utilizing of BIM, digital twin, and doing an offsite and modular construction, instead of creating a plant room at, say, level 54 to level 55, instead of doing all the welding and all the other elements up there, we can conduct majority of the component manufacturing and prefabrication off site. We can bring on site, we can host it to the top of the building, okay, and then we just do an assembling instead of doing that construction at site. So this slide is only covering in terms of what exactly the built environment stands for, okay, and what are the different challenges what we see when we are designing and doing the construction of the project. In terms of covering the generic value for the BIM point of view, BIM for built environment benefits is what it gives you is design visualization, which means that when we are designing any component of the project, we will exactly know what are the limitations in terms of installation, in terms of the available space, in terms of the size of the plant room area, in terms of the operational load, in terms of how the equipment is going to get bring into that plant room space, and how the equipment is going to get out of that plant room space. Which wall has to be concrete in situ wall, which wall can be a removable wall. So all those decisions we can easily make at the time of designing when we are working in the BIM. And even we have some tools available which can do designing based on construction support, and when the construction is finished, they can start showing how the building is going to operate during the operational side of things. So we have those tools available. It's all about how we're going to plug it into it. Nowadays, other benefit what we have started getting is energy analysis side of the things, in terms of how much energy this building is going to consume from electrical point of view, from a water point of view, and from an individual system point of view. In the past, like I think 10-15 years back, we have different tools that we utilize for doing energy analysis. Then we take those input into the system designing, and then that inputs go into the AutoCAD side of the things. Nowadays, we have tools available or plugins available which we can plug into different BIM tools. where we can start doing the energy analysis while we are designing. Although it's still not reached to the level where the design and engineer, they have a full confidence for a large scale building project. But for a smaller building project, like a residential project, small commercial project, small offices project, we have started receiving values where, as a designer, we are having a lot of confidence that this is definitely working. At the same time, the tools what we utilize is like they have a system limitation. So the moment the models start getting bigger, we need heavy system. Yes, we all know that quantum computers are coming, but still they are a little bit away from our purchasing point of view. So we are utilizing the system capabilities that we have with us. And then when we utilize those systems, we have a limitation in terms of what would be the size of the model and what are the values we can do it at. But definitely energy analysis is on the way, and we don't see that is far away, where we will start extracting the full-time data of energy analysis during the time of the designing cycle instead of using a third-party software. Material and resource optimization, that is adding a lot of value in terms of BIM modeling. And nowadays, what we have started seeing is majority of the architectural elements, as well as structural elements, and especially MEP elements, we can accurately model in the BIM environment. We can put parameters around it very correctly, and then we can extract easily their BOQ or bill of quantity directly from the BIM processes. And when it goes to the designer, and he can see, like based on some of the rule of thumbs what we have been utilizing, still that the design is heading in the right direction or design is not heading in the right direction. Okay, so material and the resource optimization can also be done during the time of designing, not in terms of when client pick up our calls and they say this is not within our budget. So it gives us opportunity to optimize material and the resources during the time of the design, not when we issue the issue for construction design drawings. Collaboration and communication is the best part of the BIM. This is the thing what we really like about BIM softwares or BIM modules. I can give you one of the example of the project which I also participated. The project was based in the US. Some of the structural team members, they were based in New Zealand. Some of the modular team, they were based in Bangkok. Some of the modular team, some of the specialized services, they were based in the Middle East. MEP was done in Australian office. So the design started early, first thing in the morning, like it was like a purely like a East-West concept. The design started getting picked up early in the morning in New Zealand, then it comes to Australia, then it goes to Asianic countries, then it moved to Middle East, then it goes to the North American countries. So literally on a single project, the way the team was being set up and the way the communication was happening, that project was operating literally 24/7 at any given point. Like we were looking into the online cloud, and at many times we have seen like 35 or 40 team members, they were working online, and changes we can check real-time changes as well as we can have a live changes. There are certain pros and cons in terms of the checking the real-time changes or a little bit of delay changes that I can go into that maybe during the question and answer session. So it's really helping or putting a solid ground in terms of collaboration and communication, and that is the key strength for any complex projects. Like we are definitely out of that era where we wait for one engineer inputs, like in terms of the location of the panels, in terms of location of the plant room area, in terms of the location of the size of the rooms, okay, and then waiting and then updating our model and resending it back. Now the way we do it with the latest online tools available, we can collaborate in real time, and even there is a chatting module available. There are video conferences tools available, and we can share our screen and we can directly coordinate with the architect who might not be sitting next to us or who might not be sitting in next suburb or even the next country, but the collaboration can happen very effectively. Nowadays, I'm sure everybody in Pakistan, they are aware there's a huge market growth happening in some of our neighboring countries, and there's a huge potential for us to collaborate and communicate with those projects if we are well aware of the modern digital tool available. Engineering, there is no doubt, Pakistani and overall Pakistani market, they have very like next level engineers, but the modern way of engineering and the modern way of collaboration is definitely changing. And I believe we as a Pakistani professional or Pakistani engineers, we need to start thinking about how we can embark onto those journey. Okay. BIM for build environment. The next one is facility management. As this is a very common scenario, if you are looking into any old building, and when we go and when we go and check an old building, one of the things which we don't find is the as-built drawing or the existing design drawings available. Especially for the MEP point of view, I'm sure for structure and the civil side of the things also it can be a problem. So one of the best part of BIM for built environment is we can add all the data into the BIM processes, okay, and that data will be readily accessible to the facility management operational team. I'm sure some of you would have seen the videos available online where individuals, they are scanning a barcode and then they are walking into the project sphere where they can see what are the type of pipes which is running below the slab or in the false ceiling area instead of opening the false ceiling. The same thing is happening in structural engineering, where now the tools are available where if you scan the barcode, you can see where exactly the location of the rebars are there, or where exactly the beam and the column running in the slab if they are not below the slab beams. So these tools are really helping the engineering professional to make the right decision at the right time during the facility management phase. Even though the design has been over, building has been handed over to the facility management team, but there is still data available which is really accessible by anyone. When it go on site, you guys can visualize what exactly is happening. And the best part about that is even if somebody's going to get changed, the models are available. The new designer will come, he will get all the background information. They can make the right decision for the modification. They can update the model. They can replace the existing.
I have to stop you there. I have to make an announcement, please.
Go ahead.
Kindly, all participants, please see, I had made an earnest request at the start that it is those who have registered for CPD points, they have to keep their webcam on. They have to appear live. This is a regulation which is issued by Pakistan Engineering Council. So therefore, don't make our job difficult. Only those people will get, those participants will get the certificate who will appear live. And if somebody is not appearing live for most of the time of the lecture, so PSC will not be able to issue the certificate. So kindly keep this thing in your mind that we are helpless in this situation. Thank you. Khurram, continue, please.
Thank you, Darshan. Okay, so then the next point is the construction support. As I said, if the data is available correctly from a design point of view, when the builder gonna come or when the contractor gonna come, they will have the full access to that information. Okay, and okay, apologies. I'm so sorry. A little bit of distraction happening at mine. Actually, my son is not well, and I'm just getting a message on WhatsApp as well. So apologies, but anyway, I'm gonna continue. But excuse my distraction a bit. Okay, construction support. So when the builder gonna come and when the contractor gonna come on site, when they have all the right information about the site, they will make the right decision. And you guys can see on the screen, like this is the level of details what we get when we design the system in virtual environment. Okay, so there is no like majority of the time there is no ambiguity available during the construction cycle, because everything is well coordinated in the background and everything is full on spot up till to the tolerance level of 0 millimeter. So yes, unless and until we have a construction tolerance of structure, say like 20 millimeter or 25 millimeter, everything is well on, fully spotted in terms of the coordination side between all the disciplines, which include architecture, structure, as well as the MEP side of things. And one of the best support what we have seen in the first world countries is the modernization and the offsite construction, because the cost of the labor is very high in the first world countries. And any labor sitting idle, it's cost a lot of money to any contractor and any builder. With the utilization of modularization and offsite construction, that has saved a lot of values. And also hot work permits, in terms of doing any work which is not allowed under the safety rules of any certain council or any certain city, that can be done in an offsite yard, where they can do all the hard work, where they can do all the connection work, and they can bring the module. They can just do the connection and move on to the next phase. I hope you guys can see the cursor on the screen. Like, this is one of the riser fabrication was done, one of the project where up till 3 floor connections, ducting, piping, and also each floor connection has been done offsite. The module was brought on a 40-feet container in the middle of night, side crane lifted up, put it in the riser. 2 guys went into it via the scaffolding. They just done the bolting, tuck, 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 move on, and they just came out. I think the whole process took maximum 2 hours in terms of lifting, installing, and removing the 40-footer container from the site. So that is where the real benefit what we have started saying, because then the constructions guy, they don't need to go on site. Only the fabricators, they have to go on the site for doing the final connections, and remaining work will be handled by the logistic team. Okay. Another benefit for BIM for built environment, design constructability and life cycle assessment. The complete design can be done fully in BIM. The constructability reviews can be done in BIM. So say, for example, if one of the designers, they say we have to construct this particular element in this way, we can come up with a certain scenario of, like, if we do the construction in this way, or if we do the construction in this way, this is how it's going to look like. Okay. So those can all be done in the virtual environment instead of doing at site. Okay. And once we know what would be the main construction method for that particular module, we can do the complete life cycle assessment at the same time. Okay. So these are some of the very high level benefit of BIM for a built environment project. Okay. And you guys can see on the screen, like, what this means for a built environment. Okay. So the previous slide was covering the benefit, but in terms of the level of efficiency, the level of accuracy, the level of design suitability, we can reach to this level, if you guys can see on the screen, which is like we can do a complete virtual or digital construction offsite. Okay, we can do all that while sitting in an office, and to the tolerance level, which is similar like what we see on site. Okay. One of the another important aspect what we have noted is design ownership and responsibilities. Start or shifting back to the main designer. Few people or few individuals, they take this thing as a pro, few individuals, they take this thing as a con, but we take this thing as a pro, because if we finish the design and if we have done the digital construction the way we want to get it done, and when we issue the model to the contractor, one of the instructions what we give to them is like, you need to look into the model, and if there is any question, you need to ask us. But if everything is okay, good to go, you're not even allowed to change anything on site. Simple. Like, they can't move the duct a little bit up, they can't change the pipe connection from left to right, because everything is literally coordinated. So although the designer always own the design, but even utilizing BIM, the designer go to the next level and own the design more than saying we need to review the design within the shop drawing to review level. So we have done some of the project where when we issue the drawings, those designs were literally reached to the shop drawing level, where contractors just need to pick it up. Even the quantities were being extracted directly from where they need to purchase those quantities. They have to do offsite construction, bring on site, just just connect everything with the system, okay, and move on. Okay, so if contractor has any issues, they can discuss with us before cutting any material. Not that when we reach to the site where one of the contractor who started working on job, he has picked up the space already in the ceiling space, and they are not letting, say, like a fire contractor or mechanical contractor to run their services. That whole process is being totally or can be eliminated by utilizing BIM for the built environment project. One of the best part, which I personally love, is the minimum abortive work. Okay, we are doing projects where all the coordination between architecture, structure, and the MEP services get done in the virtual construction environment. Number of panels, even to the level of 100 millimeter, we get coordinated in our offices. We do the coordination with rebars, we do the coordination with the beams, columns, ceiling levels, okay? And that really help us in saving a lot of cost, which comes or which we see on the project from the abortive work, okay? So this is one of the benefits what we have seen. The formwork construction, how to handle the opening at site or conducting the abortive work has literally minimized in some of our projects where we have utilized BIM services. Okay, so that's a lot of saving we have seen. Like we have done a few projects where things were not being coordinated early, and some of the floors we have to do around 200 millimeter opening, or in some cases 150 millimeter opening, say around 40 or 50 on one single floor, and that building is around 22 or 23 story building. So you can imagine the level of work which is gonna go. Although in Pakistan, individuals say labor is very economical, but when we always say if you just start piling up those labor costs, you will be amazed to see how much saving we can have by minimizing the abortive work. Okay. Next important item is optimization of construction waste and time. This is again related to item number 3. We can literally reduce the construction waste. I'm going to cover this item a lot in my further slide, where I will be discussing about the modularization and offsite construction. Okay. Item number 5, clarity on the project life cycle. Cost is very important in Pakistan, like countries like Pakistan, where the cost of the materials keep on changing. If we do the construction in digital environment, we can log all the equipment, we can log all the materials, and we can even log all the equipment as well, in terms of their accessories, in terms of their small minor items such as like even hangers or even screw. We can do the very clear bill of quantities, and we can utilize some of the tools available in BIM environment where we just need to add the cost on a daily basis, and we will have the full life cycle cost assessment on the project. That's one element. And the second element is like the moment you change any of the design item, the cost will automatically get updated if you do the modeling in the way that it will automatically get reflected. So these are the options available in BIM environment. Item number 6, which is more connected with the digital twin, which is the data-driven building operations. Instead of just operating building for the sake of operating building, the facility operators, they will have an opportunity to get the design data, and then based on design data, they will make the decision like, this is how the building is being designed. This is not currently being operational. What are the issues there? So based on those data, they will make sure the building operates in the best possible. And important item, asset management. Once everything is being constructed, those equipment and the machinery, they have to be managed properly. And with BIM environment, asset management can be done in a very cool way, because we can generate barcode for every single asset. Whenever any maintenance guy, they go on site, they just need to scan the barcode automatically in the real-time data. If you have a cloud server activities available, we can do the maintenance services, and everybody in the facility management team, they will have an idea about what is this all about. Okay, so asset management can be very easy if you utilize this these tools, because the designer can tag the asset in the way they want to tag the asset, and that same information is going to go to the facility management team. They don't have to do any sort of a tagging unless they replace their certain equipment. Okay, so asset management get very easier while utilizing these processes. This is just a snapshot of comparison of drawings. When we say 15, 20 years back, when I started working onto the projects, the drawing on the left-hand side, we used to work on those kind of drawings at that time. But when we embark on the journey of the BIM tools, our drawing started looking a lot better, okay, in terms of clarity, in terms of visibility side of the thing. And nowadays, our drawings or our documentation looks like this. Okay, so around 5 years back, when I used to work for another organization, they were discussing about not to issue any paper-based drawing anymore. So their issue for construction drawing were not gonna be the PDF or the CAD files. They were discussing about how to utilize models to be issued as issue for construction model, where the contractor is going to take up that model and build it as it is and do not change anything. So this one looks like to that level. Personally, as an organization in which I'm currently working, we have not done yet because of certain limitation, but there are certain organizations in the world, they have reached that point and they're practicing that. Okay, considering this forum is for civil and structural engineer, I extracted some of our projects where we have done the structural modeling, and you guys can see that. Of course, you have tools available where you can do this visualization, but this is all coming from BIM environment where we are actually doing coordination with other elements. So for some of these projects, we have even done the modeling up to the rebar level, and we are doing the coordination even rebar versus the penetrator versus the panels. Okay, obviously we have not done any analysis, structural analysis yet into the BIM environment, but yes, there are tools available or plugins available where we can also start doing it. We are MEP consultants, so we don't go into that extent, but anyone for a structural modeling, when we do, we don't go to that extent, but there are certain tools available, plugins available where you can do analysis, similar like the way I have mentioned about the MEP system, where we can do energy analysis side of the things. Okay. Okay. Now is the next topic, which is the concept of digital twin. As I said, BIM is more about design and virtual construction. Digital twin is all about Internet of Things, which is we call IoTs. We get the building design data from the designer and from the construction team, and the facility management team, they use the concept of digital twins to make sure the building operate as per the design and as per the user requirement. So in snapshot, digital twin is basically a dynamic digital replica of a building or a system based on the design input values. Okay, and there are a lot of other categories of digital twin, but the digital twin which is applicable to our industries, there are 5 categories, but we always say, which is one is descriptive twin, the other one is informative twin, third one is predictive twin, especially related with MEP services. Fourth is, by the way, predictive also related with the structure side of the thing, where you guys do structural analysis and building stabilities. Then we have a comprehensive tab, and then we have a autonomous twin. Okay. Due to the time what is available, I'm not going to go into the detail of individual twins, but a lot of information available online, and you guys can have a look into it. Now, what is the benefit of digital twin for a built environment project? One of the item is optimization. And when we say optimization, because digital twin is all about the data driven. So we get the data from a BMS system, from an EMS system, from other digital system, what is installed, which monitor the progress of how the system is operating. So we pick up that information, and then we have also the design information. Then we overlay both of these information, and then we see where exactly the issue is happening. If there is a certain area which is consuming more energy or more air conditioning power or air conditioning capacity, we can do very easily optimization, because we have the design information available, which is the digital format, and then we also have a actual operational data available. So we can compare both those, and those can be easily monitored via the digital tool. Okay, on a daily basis, even on 15 minutes interval basis as well. But for our MEP systems, I don't think 15-minute interval is like a true stretch. So generally what we do is we compare on an hourly basis or half-day basis or a daily basis, because if you go into 15-minute or even change of value interval basis, it's a lot of data, and it gets very difficult to analyze those data. The second benefit of digital twin with BIM is performance monitoring and analysis. Okay, optimization is one item, but we can do a continuous performance monitoring and analysis of the system at the same time. Okay, the third item is the predictive maintenance. Okay, since we know certain equipment need predictive maintenance, say after like 3 months or even 6 months or even 1 year, if we have set up everything in the way that it will generate messages or signals to the individual who are managing the facility side of the thing, they will receive this information and they will say that now this maintenance need, now this equipment need maintenance, and they can organize their maintenance activity accordingly. Okay, so digital twin field help the facility managers or even the building operators to make those decisions. Life cycle optimization, as I mentioned about the BIM, like we can do the life cycle optimization calculation, but with digital twin, when we plug in those data, what we receive from BIM, we can do actual life cycle assessment. We say, like, say, for example, on June 27, 2024, we predict that total energy cost will be, say, 1,000 kilowatt hours, and on that day the total consumption of electricity came up, say, like 1,500 kilowatt hour. That will raise an alarm in the system. So someone has to look into it and say, okay, there is something happening outside the design condition, and factors can be huge. The factors can be huge in terms of maybe the ambient temperature has gone above the design condition. Instead of that day 45 degrees C, the outdoor temperature has gone to 48 degrees C. So all those analysis can be done very, very easily in terms of the life cycle optimization side of things. For a smaller system, it doesn't matter. But when we are talking about, say, like a 50,000 refrigeration ton of equipment or 100,000 refrigeration ton of the, these smaller kilowatt changes impact a lot in terms of the operational cost side of the things. So life cycle optimization can be done in the real time scenarios. Okay. Occupant engagement, we can do on a regular basis. On a daily basis, we will know about the space temperature, space humidity, and the space equipment, how they are delivering the design condition. And if at any point, if you see that the things are not in terms of the design values, we can get in touch with the occupants and we can seek their inputs, what they feel about the design condition of that particular space. At the same time, occupant also can give their feedback directly online to the digital twin platform, so that the operator and the facility manager they can also understand what's going to happen, and based on those decisions, they can make the equipment operational decisions. Very important item, energy efficiency reviews. Energy efficiency is getting very important in first world countries because of the cost of the utilities, but at the same time, in the second and then the third world countries, like even a country like Pakistan, is getting very important, because the cost of electricity, rupees per kilowatt hour or dollar per kilowatt hour, is going in for an increase, and we foresee that this rates are not gonna get down. They will be always on uphill. Okay, so one of the country where we operate, we noted a huge increase in the demand charges. So the utility cost, say it was, I think, 37 or 40 rupees per kilowatt has jumped into like around 60 or 65. Please don't quote me on this number, because numbers are not 100% correct, but around 50 to 55 or around 60% electricity cost increase. So for any operator, it's a tough challenge, because they have to produce air conditioning, or they have to run that building so that the occupant of the building, they will get their comfort environment. But since the cost of the electricity is going up, that is causing always a challenge for them. So energy efficiency review can be very easily done, because the energy engineer who's looking into a building from an energy efficiency point of view, they can look into the design data, they can look into the digital twin data in terms of operational side of the thing, and they can compare what happened in the last 1 year, 2 years, or even maybe 5 years, and they can come up with their suggestion how to reduce the energy consumption of that particular area or that particular building. So energy efficiency review is getting very, very easy by utilizing these technologies. Indoor environmental quality is very important for a lot of occupants. They are also important from environmental rating tools such as like LEED, BREEAM, Green Star, and I believe Pakistan also have started something in terms of energy efficiency side of the thing. So utilization of these tools can definitely help us in terms of identify where exactly there's a problem in terms of indoor environmental quality and what can be done about it and the things. Water management, very important in terms of the water wastage. If, say, for example, you have meters installed in the incoming line in terms of the overhead tanks and in terms of monitoring the utilization on each floor basis, on a daily basis, if any particular floor or if any particular building, they have got increase or sudden increase in the water consumption, it can generate alarm, which can be either more utilization by the occupants, or there can be a potential leakage in the infrastructure. So those can be picked it up. Instead of water getting lead all over the place, it will flood out the floors and then create a damage to the property. So there are a lot of benefits in terms of connecting your infrastructure with the digital twin environment. And as we are well aware, it's kind of like a kind of getting a bit of a buzz also in Pakistan, but in the first world countries or in the Middle Eastern market, which is all about the smart city and urban planning. Like instead of designing the individual buildings, designer or local authorities, they are going on the path of smart buildings, smart cities, smart building, smart urban planning, full digitalization connections. Alhamdulillah, we have also a project also happening in Pakistan, where individuals or I think the owners, they are discussing about converting that building as a smart city building. There are a few projects happening in the Middle Eastern industry as well. So this is all related to the utilization of the BIM and digital twin technologies. So once we have a full understanding of how this can work, I can assure everybody that like there's a huge opportunity for all of us to practice into this field. These are some of the snapshot of what can be done via digital technologies. The moment there's a variation in temperature, we can generate alarms. You guys can see that in certain days of the certain time of the day, in a week, Monday, Wednesday, Friday, there are different ambient temperature happening. Building occupancy keep on changing, but if the building is not smart, your central plants or your central energy system, they will be keep on operating on a peak load. In first world countries, they operate the central system based on the demand, not based on the peak load requirement. So these analysis, they help facility operators or building management operator to take the right decision at the right time. And then the next one is about the predicted versus actual. Predicted is going to come from the designer input data from a built environment, and actually is based on the data what will be collected as per the user. We can correlate to them. The moment there is a 5% variation or even 10% variation, then from a predicted cooling load versus actual cooling load, it can generate alarm on that particular day. Those alarm can go to the building operator and they can have a look what exactly has gone wrong or why things are not running as per the design condition side of the things. And you can do range of regression analysis, or we can do actual the plant room growth analysis, plant room capacity analysis, and we can in a nutshell, we can do a lot other things which cannot be done in a building which is not a smart building or which is not a digital twin connected building. Okay, let me have a bit of a water, please. Apologies. Okay. So in terms of introduction of the BIM and digital twin, I have given a bit of a high level overview, what can be done, what it means for a built environment, and what are the benefits overall we can achieve by utilizing all this digital tool. Now, the next topic is modularization, like how we can utilize this virtual construction and digital twin technologies for the benefits of life cycle assessment costs, for the benefits of reducing the initial construction cost, and also how we can assist in terms of the better coordination side of the thing. So now we're going to discuss a bit more in terms of what can be the outcomes of virtual construction if we go on the path of a modularization side of the things. By saying this, I'm not conveying the message that if you design building in BIM, we can't do the conventional construction. Yes, we can still do. We have projects available in Pakistan and in some other countries where certain items are getting modularized, but certain item of the system, they are following the conventional strategies. And those decisions is being made by the developers or by the client or the project directors based on the cost, based on the equipment, based on the limitation of the logistic, based on the labor availabilities as well, because the skill set of the labor is also very important. So in this section, I'm going to cover a bit more in terms of the modularization side of the thing. So what is a modularization? It's not a new concept. It's been there for ages. We have seen in car industry. We have seen in aerodynamic industry. We have seen in NASA. We have seen in so many other areas. But it's not been very common for the built environment project for the last 10 years. And since last 10 years, or maybe last 15 years, it's gaining a lot of attention. And why it's gaining a lot of attention? Because of the availability of the tools available and about the precision. Reason being, for us, built environment, almost every building or every project is a new project. But if I discuss about the car industry, say, for example, a certain product of one of the car manufacturer, they will produce bulk in terms of 1,000 or maybe 2,000 at any given time. So they can easily modularize this thing. But when it comes to us for a project, every project, we have to do a modularization based on the project requirement and based on the client inputs. Okay, so that's why it was not getting a lot of attraction in the past, but now because of the availability of the certain tools, it's getting a lot of attraction, and that's why it's getting popular these days. So modularization is all about deal with the configuration of products or system by identifying components that can be grouped together so that they can operate independently to fulfill certain requirements in a larger operation. So we are definitely not saying that we will design the entire building, say if it's like a 2 million square feet building, that we will do everything in modularization, but certain components can be easily done in modularization. So that is the component of modularization I'm picking up for my presentation. And what are the benefits of it is reduce assembly complexities and cost of handling in the transportation side of the thing. So we can definitely standardize a lot of items via modularization. And then is the standardization. As I said, standardization in a building built environment project, we can do a certain standardization, but not for every component. Say common standardization, what we have started seeing, MEP plant room, pump skids. Nowadays, chiller skids are also coming. Header skids are coming. Toilet pods, kitchen pods. Now we have also even started seeing the joinery pods are coming. They are all getting, like, in fact, the residential industry, especially in Australia, everything get designed in Australia, but all the manufacturing, material sources and everything, they get done in China with a lot of the builders. And what they do, they transport all the equipment on site. It's all about assembling and they're delivering the project. So that's already happening in Australia in terms of the residential project, but we have not reached to that point for commercial project other than bathroom pods, kitchen areas, and in some of the ceiling space, and the plant room spaces. This is where we can do a lot of standardization. Take an example, hotel, washrooms, they're very typical. So we can definitely do a standardization of modularization of those elements. But if it's like a, how to say, if it's like a large retail store, it get a bit difficult because each retailer, they have a certain design requirements. So yes, we can do a certain modularization or standardization, but we can't do everything. So it has to be gauged based on project to project and requirement to requirement basis side of things. Form of the system of the fabrication, some of the snapshots, none of them is our project. So I'm going to be discriminating that I have taken this picture from online sources readily available, but giving you a confidence as we have almost done all of these kind of projects with our current organization or with my past employers. Okay, so the confidence level is there, what we can achieve, but obviously I can't explain at this point in time what exactly was the type of the system what we have utilized. But the form of the system fabrication is there. We can bundle everything on a transportation skid. In one of these pictures, you can see that all the risers, they were being stacked up. They put into the scaffolding arrangement, tower crane, transported from the manufacturing warehouse to the site via the container for 20 feet or 40 feet, whatever. And then it will get lifted by a tower crane, placed on site, just doing the final bolting and move on. And what we have seen on these kind of the project is like the level of tolerances is so close that we have seen very less disalignment in terms of when we're doing the connection side of the things. We have started saying these kind of horizontal. When we talk about the MEP side of the things, we talk about the horizontal services reticulation as well as the vertical services reticulation. Vertical services are very standardized in MEP system because the size of the pipe, the size of the ducts, they don't get changed a lot, or up to 3 to 4 floors, they don't get changed. Even we take the offset on individual floors, but it gets a little bit tricky when we talk about the horizontal reticulation. But now we have started seeing that, and a lot of clients or developer, they are requesting for this information because they see a lot of benefits in terms of the construction. Because I'm going to show you in some of my slides, like how the construction waves look like if you follow the conventional construction mechanism. Okay. And these are some of the examples of the pump skits. Kind of, none of them was done by us, but similar things we have utilized for some of the projects where the pump kits is being designed and fabricated offsite, and they've been transported at site. Riser transportation, pretty much similar thing has happened in one of our projects, and it was so great. Like the connection of these risers took, I think, only maximum 5 or 6 days, and they were like around 12 or 13 risers all together, and the building was around 20-story building. So you guys can imagine the efficiency in terms of installation side of the things when we go on to this part. Benefits of modular construction. This is one of the things which I want to show everybody. The conventional building services. So generally what happens, and I'm sure you guys would have seen this kind of arrangement in some of your projects in the plant room area or on site. What happened in the conventional building services, we design, we procure, we do on-site fabrication, we send all the equipment on site. We all know that what is the site condition, how the equipment is being handled, how we do the cutting, how we do the covering and keep protecting from a weather condition. Then it gets assembled, then we do testing and commissioning. What we have noted from these projects, those are high waste, high labor, high cost, and longer lead time. So when we started looking into this thing, we thought, oh no, but that's is easier if you do everything on site. We can coordinate, and this element, like when we started looking at this thing, it's like 5 or 6 years back, and even for Pakistani condition, when we started looking at, although we say our cost of labor is economical, but when we plug in all the numbers, it gets expensive than the modular based cost or standardization or offsite construction based cost, because waste is very high. What we have noted, the fabricator will go on site, wherever he find a place, he will cut the pipe, say to 200 millimeter pipe or even 300 millimeter pipe. They need to have a A-frame channels, they need to have a lifting arrangement, they need to have a 5 or 6 meter holding that unit. So from a safety even point of view, it's not very safe to work into those conditions. But imagine if you are designing the same thing, and I'm going to go back to your slide. If you're designing this big header, and if you're fabricating this header in a workshop, you can have an overhead crane, easily lifted up, very safe, bolting and everything can be done very safe and very nicely in a fabrication warehouse. So that's where we can save a lot of cost. Okay, and our site condition will be a lot cleaner than what you guys can see on the screen. And this is one of the examples I have shown you. Like it's a lot of work which has been happening for a horizontal reticulation, but you guys can see that it's only lifting arrangement and then only the connection arrangement. That's it, nothing else. Like floor is plain, I'm sure when they were taking this picture, they made it very clean to make to sell their product. But we have seen on site, like this is literally we can achieve easily. Okay. So one of the benefit of modular construction is we can have a almost next to none waste, labor cost reduced, but obviously we can't make it done. Cost slightly lesser than a higher cost, and less time in terms of the fabrication side of things. So these are the benefits that we can achieve from a modular. And when we go into the prefabrication, which is off-site construction, what we do, we design and we keep on designing. We procure while designing. We do off-site construction, fabrication. We manage the transportation. We assemble. And when we say assemble is all about connecting with the wider system. And then we do the testing and commissioning. Testing and commissioning can be done in two ways. One in the fabrication warehouse. We can do the leak testing of the component what we have put as a module, but the full system testing will be done at site. And what it result in terms of, it's a low waste, it's a moderate cost, it's a low labor, and it's efficient time, which is the less time. That is what the benefit we're going to get in the prefabrication side of the things. And in terms of the manpower saving from a trade level point of view, what we have noted is like we can do certain assemblies instead of going on the path of doing offsite construction for everything. We can go with we can select the prefabricated prefab component. A lot of suppliers, they have started issuing pre-insulated plastic piping. That is all related with the designer in terms of making the decision of what type of component they want to use. But now a lot of suppliers, they have started issuing the prefab component. Then sub-assemblies, which include MEP services only, or we also have integrated architecture and structure component. And in this one, you can see that the ceiling is already prefabricated. Even the glass is offsite assembled. All the ducting and the piping, they're already installed. It's just a matter of bringing this phase on site, hooking it up, connecting, and move forward. Okay, so this is for a horizontal prefab. And then we can go on the path of integrated assemblies, which is the prefab plant room, which I have discussed about. We can design everything in terms of the component side of it. In sub-assemblies, we also cover prefab plant modules, smaller, not the bigger version. Certain module of the plant, now the entire plant room, and then also the prefab vertical riser module with the catwalk system, which is only there for the connection side of the things. So in terms of the labor, manpower saving, if you go on this part, you can save around 30%. Sub-assemblies, you can even achieve up to 60%, and overall man saving, you can go on the path of 70% work hour saving. And this is what we have seen a lot happening in the overseas market. And this is a quick comparison of a conventional on-site labor based delivery versus off-site delivery. And you can see that there's a huge efficiency what we can achieve in terms of cumulative hours based on-site labor delivery, on-site space construction versus the off-site delivery. And here I just want to disclaim, apology, there are certain spelling mistakes available, but I have copied this thing from one of the papers. I couldn't change it, so apologies for that. And in terms of the plant room construction case study, we have done that based on the conventional plant room construction schedule, which include system design, on-site structural work, equipment arrival and handling, pipe cutting and fabrication, on-site installation, rework / commissioning. So altogether, it is taking, the conventional part is taking around 29 more days in terms of the modular construction, where you guys can see that initial design is taking a bit longer time than the conventional, because there's a lot of complexities involved into it, but on-site structural work remain the same. Module and arrival and handling, that's where the optimization of the days is. On-site installation and final commissioning. Instead of doing in 20 days, commissioning and other installation work can be done in a very efficient way. So overall project saving, what we have noted was around 29 days. And for any builder in first world country, that's a huge cost saving. And that's why we have seen that a lot of interest is coming up in first world countries in terms of prefabricated construction on site. What are the factors to consider when designing for modular? On-site logistic. what are the logistic facilities are available? Like we can do anything offsite, but important item is how to bring that on site, which is the shipping and road transportation, and how to do the corrections. So those are very important. Okay. System functionality, it has to be very clear, and that can only be easy, or that can only be done if we have a full understanding of the entire design. We have seen the design in virtual environment. We exactly know what are the systems conifer, and then we can divide the entire design into smaller components, and we go with the system functionality basis modules. Okay. Item number 4 is more of a maintenance and replacement. Okay. Just give me please 1 minute. Sorry, everyone, apologies for this break. System functionality is also important because that defines how you're going to convert the individual system into modules. Okay. And maintenance and replacement is also playing a very important role, because you need to know exactly how the system is going to come in, how it will get maintained, and how it's going to get replaced. Okay. And important element is how to divide the complex assembly into smaller components so that it can be easily or fabricated offsite. Okay. And the whole factor what we are designing for modular is more of a design reputation. The more we have a design reputation, the better saving we can get in terms of the cost, in terms of the labor cost. Okay. So design reputation is very important. Like if we say we have only one floor and we want to do a modular construction or prefabrication, we will recommend not to go onto that path. But if we have, like, say 1,000 washrooms, or if we have 1,000 kitchen area, which are typically same, then we will definitely recommend to go on the path of the modular construction. Okay. Okay, some of the, as I said early on when I started discussing about the modularization, modularization is not a new concept. Okay, and it's been practicing in terms of air industry, in terms of the car manufacturing industry, as well as the standard process industry. So one of the concepts what we use for modularization is called DFMA, which is designed for manufacturing and assembly, which has a lot of standardization of modular components, interchangeability of parts, simplicity of connecting parts, consistent sizes, predictable build/assembly processes. Okay, so I gave an example of if there is a certain model of the car, the manufacturer, they will go in terms of like 100,000 car or maybe 1 million car. So it's very easy, but it gets difficult when we go on the path of the build environment. For us, build environment, every project is a different project because what happens is the size of the risers get changed, the size of the system just get changed, and just keep on changing from project to project point of view. So the way we assess that which project has to go on the modularization or offsite construction is we follow the performance measures. Okay, so what we do is we go in terms of the initial design, we check the functionality, we see whether modular flexibility, adaptability is possible or not, and if answer is yes, then we go into the sustainability and performance. If you go on the path of if you're making a decision that we're going to go with the offsite construction, we need to go into the structural side of the thing for the project. We need to look into the thermal and acoustic properties of the side of the project, and also the cost and the energy or the effort which is going to be put into that path. Advanced manufacturing, that is very important for Pakistani point of view. We need to look into the project where we need to see do we have the skill sets available in the contractors, whether they are even ready for going on the path of this journey. In Australia, especially, a lot of main big players, they have converted their construction mechanism following this mechanism, so they are fully geared it up now. Like, in fact, I know one of the contractor, they are designing their item in Australia, but their plant room manufacturing, their header manufacturing, they're getting done in China even. So they have gone to that level where by utilizing BIM tool, by utilizing digital twin applications, they have streamlined 2 offices in different continents, and they're working very well. So advanced manufacturing is very important. which define what is the manufacturing time, what is the material usage, and what is the number of defects we can expect in terms of going on the path of modularization. And handling and assembly is very important. We can't design the entire project off-site because shipping and logistic plays a very important role in terms of delivering sub-assembly from a contractor warehouse into the project site. Okay, so sub-assemblies are important, final assemblies are important, total parts are important, and most important thing, transportation. I can give one of the example. I read a case study where one of the leading companies in the world, they have done some prefabrication offsite, and transportation route was not fully being assessed. And when they were planning to do the transportation of some particular modules, they came to know that there is a particular bridge which does not have the load bearing capacity for this additional load which can be put on the logistic. So these are the important items. Like we can do offsite construction, but we can't load it to the level where the authorities or the infrastructure does not allow you to overload your vehicles. So we have to consider those elements as well. I'll be open and frank with you. Like we might have a project in Islamabad and we are doing a construction in Lahore, and we are trying to ship that module from Lahore to Islamabad. Motorway might not be even let us do that. So we need to consider all those elements when we are designing, or when we are selecting that, we are definitely going on the path of offsite construction. And design optimization, which is a continuous process. When we start looking into the modular construction, and when we start looking at the performance measures, we start looking the optimization of the design, because that all sit with the designer and it doesn't sit with the contractor. Yes, contractor do get involved, but only for a constructability report. This is the norm of the first world countries. The designer, they take a full lead, but contractor, they generally get involved from a constructability review, whether this can be done even or not. So that's where a lot of collaboration happens between the designer firm as well as the builder and the contractors. Just a snapshot of to give everybody a confidence that this is not a new concept. It can be widely applicable, which is modernization method in other industry. There are some studies which was done. Himmler is one of the guy who has done the study for the jet turbines, and they have followed the design structure matrix for a DSM. Frankly, not going to go into this thing because a little bit short of time as well. So, but this is not a new concept. The only takeaway for us is like how we can utilize this concept and apply into our built environment project from all the elements, which is architecture, structural, MEP services. Type of modularization, we got two structures available. One is called functional structure. The other one is called product structure. Functional structure covers the functional constraints and the system life cycle, whereas the product structure covers the site constraint, transportation constraint, and replaceability. Okay, so we have to look into it, what type of modularization we have to, we are going to go with a certain project, whether it's we are going to divide the project into functional structure, or we're going to go on the path of a product structure. Function grouping, this is one of the glimpses of it. Like we have a huge plant room available, and what we can do is we can divide the entire plant room in terms of pump modules, header modules, piping modules, support modules, chiller modules. That is all depend upon the functional. Like we can have a pump, which is S1, we can have a 3-way valve connection, which is a different category. Then we have another pump skid, which is pump skid number 2. Then we have a dosing pot skid. Then we have a filtration skid. We just need to do it offsite, bring them up, just connect it into it and move on. Then same goes for the functional. If you can do with a chiller connection, we can have a pump one connection with a dosing pot. So that's how we do it. And in the end, you guys can see it gives a very clear outcome for the project. Then we have seen also the physical modularization. This is not, we don't recommend, because on site we have always a lot of a limitation. But as I said early in my presentation, that there is no way what BIM state that we can't follow the conventional one. But yes, we can utilize BIM services to do the physical modularization at site as well. Okay. Generally, what we have noted is hybrid construction strategy, where we do certain component as offsite manufacture and then certain component as at construction site. Okay, so Offsite factories we can establish for the plant room modules, we can establish for distribution modules, we can establish for ports, whereas the equipment we have noted because of the size and because of their operating way, we have noted that it doesn't make a lot of sense that do those fabrication offsite and then bring it on site. So generally what we do is we supply equipment like larger equipment such as like chillers or the cooling tower. If they're coming in a single piece, bring on site and then do the connection side of thing. But generally what we have noted is the proposed hybrid construction strategy works a lot better. Nowadays, what we have noted in that, especially in the data center industry, the shift between hybrid is more of offsite construction around 80% and the remaining 20% is outside. So things are definitely changing. A lot of modernization has happened, and because of those modernization, we are picking up a lot of benefits in terms of offsite construction. BIM for modular. What BIM can do for modular construction? I'm going to touch base some of the basic definition of BIM, which is important. That's why I thought I'm going to put it into it. And those are like level of construction, level of coordination and class detection, what would be the manufacturing model, and then the construction, which is we call as 4D. Now we can do a virtual construction and we can also do the planning out of it. So I just included 4D. I have not gone on the path of 5D or 6D because that is a total different ball game, and unfortunately the time available to me is not going to give any justice to it. So that's why I didn't include it into it. Whenever we talk about the BIM, the first question always comes is what is the level of development? Either we say a level LOD, or nowadays we have started hearing from some of the people or individuals as LOD, LOD, LOD. So level of development define what is the development level we're gonna give. So if you guys can see on the screen, there are different type of fixtures what we have seen. It's all about the level of details what we are putting into the model. Just excuse me for a minute. Okay. Apologies, excuse me. I told my son is not well. My wife, she took her to the hospital. So, but anyway, finishing. After this, I'm going to run. So level of development is all about what is the level of input we're going to put into the concept. Okay. So generally, if you are only doing concept in BIM, it's called LOD 100. If you are doing the design model, it's called LOD 200. If you are even going on the path of the construction model, we do LOD 300 or 350. Okay. And if you go on the path of modernization and prefabrication, then it's called, we go on the path of LOD 400. And if everything is done in BIM as per level we achieve, like everything is fully done in BIM and digital twin, then it's called LOD 500. There's a lot of misconception available in the market where BIM is for sale. It's a big elephant, but it has also associated has a dollar cost to it. So we need to be a little bit careful what exactly is required for the project. And based on that requirement, we need to pick it up. What is the level of development we have to go? Like take an example, if it's a very simple or straightforward project, and if somebody will come and say you have to do LOD 500, we generally recommend you don't need it. Up till LOD 300 or 350 level is more than enough for your project. But as I said, the more higher LOD we have, the more expensive the project will become. Okay. Okay. Then the so sorry, and this is representing the coordination. What we achieve. This is one of the item of the BIM, because we can't go on the path of modular or offsite construction if our design is not complete. So you guys, you can see on the screen that this is the level of coordination we have done some of our projects from MEP point of view. We are not showing or discussing about the architecture and structure side of the thing. But the moment we reach to this point of coordination, we can start thinking about the modelization. But if you don't have this level of work being put into BIM environment, it get a bit tricky to go on the path of modelization or standardization of the projects. Okay, so this is just a glimpse shot. I want to show to everybody that this is the level of coordination or effort. It goes into different level of development details. It will look very simple if it's only LOD 200. The moment the project owners, they start increasing the level of details, it start looking a bit more complicated. Like take an example of this one. This does not include hangers details into it, but certainly you can see that the pipe is running through the penetrations and it's accurately coordinated. But this one is being done up till LOD 350 level because we are extracting the quantities directly from the model. So the number of hangers, the spacing of the hangers, the number of screws and the bolts all has to be extracted from the model side. Important, once we have all this information, what is the BIM process for modular construction? It's 2D, can't do. 2D has to go into BIM, BIM has to go into cost, cost has to go into fabrication, and then it has to go into installation. Initially, we do basic building design and project, development of BIM models. Straight away, we can go on the path of design analysis, which is a structure analysis, sustainability and building performance analysis. As I mentioned earlier in my presentation, this is all can be done. Still, for different trade, for different discipline, for different components, it varies. Improving BIM for prefabrication, improving BIM for factories, costing and quantities, which is the material quantities and cost of fabrication, site preparation cost of transportation on and installation, and manufacturing process and planning, which is fabrication using CNC. All the tools are available. It's all about how to define the process. That is the most important item. Okay, and conducting the testing and the commissioning, which is the last testing, which is the field testing, which I have covered in few slides back. Mass manufacturing and site preparation, transportation and installation. So these are the full process we have to consider for the BIM process for a modular construction. Yes, certain process can be skipped, but it all depends upon the level of detail what we go on to the project. Okay. So far, I'm tracking well with the time, and I only have got 3 more slides to go. And I think we should be able to finish it up in 7 to 8 minutes time. This is one of the project we have recently done. And although our engagement does not include 4D construction, but we have done this in order to show the values to the owner, to the developer, to the installer, that what can be achieved via BIM. 4D construction include BIM related data for architecture services, structure services, as well as MEP services, but then it also need a Primavera programming. And then we just integrate all of that and do the visual demonstration, and then we can interlink together. As I noted, and this was not a part of our contract, so certain thing, one of the thing is you will see the tower crane, they are not moving, but they are there. They are there for actual. We have not put a lot of effort into it because this was done just to show to the client that this is the value or the power of what we can achieve. Keep one more thing in mind. Certain things may not be 100% accurate. As I said, we were not engaged to do this work, so we have not gone on with this stuff. So based on the project Primavera schedule, the retaining structure is coming up. Dates are coming directly from Primavera inputs. Results. You guys can see columns, they are start coming up in phases. Slab work or framework is also coming up. Boring we have not shown because that take a lot of time. So for this project, architecture model, structure model, and MEP services was developed. It was linked with the Primavera schedule. And this 4D construction, we are only showing from a structural point of view, because if I'm going to show all, it's going to take a lot of time. So that's why we haven't done it. But this is how the ground floor structure is being done. And then things are going to go up for the upper floors. Cool. So this is the video showing up to the top slide. And the next one is basically a case study for a project in Qatar that is all based upon modernization and offsite construction and how the growth of hospital is going to be. Some of the participants might have seen this one, but this is where the world is heading. Hey, Kara. Okay. And the last slide before I go into the final question and answer, I just want to give this present to all the participants. If you guys can search this QR code, you can actually see how a plant room look like in the digital environment. So just do a QR code scan of it, and you would, like, if you scan this QR code, you would be able to see the plant room which is being installed here. And if you scan this QR code, you will be able to see what are the all system which is being there. So I will just take maximum 15 seconds more and then go to the last slide. Considering everybody would have taken the snapshot, I'm going to move to the next one, which is not a question I'm putting forward, but a moment of thought for everybody. But I have just discussed and showed to everyone, what does this mean for Pakistan industry? I should have written for Pakistan construction industry. Apologies for that. But yeah, what does this mean for Pakistan construction industry? And what does this mean for Pakistani professional planning to practice in global market? Thank you so much. Over to Tahir, sir.
Thank you very much, Khurram. It was a very nice lecture and very informative. Since it was not my subject and I'm not very up to date, I really learned a lot. But I would request Rizwan Mirza to conduct the question answer session and his comments on today's lecture. And after the question answer session is completed, then I will make the final announcements. And to the participants, I request if you have any questions, please type them in the chat box. And if Rizwan can see them, he will read them. Otherwise, I will read them and the speaker will answer them. Thank you. Rizwan, please go ahead.
I think Rizwan Business Service muted. Tahir, you're also muted.
Okay, in the meantime, I think Rizwan is having some technical issues. At his end, his microphone maybe is not working. So I will ask the question. There are two questions now. So the first one is from Jan Mushtaq. Tahir Saab, can you hear me?
Can.
Okay. He's asking, Zan Mushtaq is asking, can you please tell some about connection types in context of modularity MEP components?
Sure. Good question, Zan. Then, depending upon the type of the system, say if we have a piping system, say chill water system or fire piping system, we have final connection. We can have a welding connections. Okay, but one of the reason of modular construction is to do construction offsite is to avoid hot work at site. So generally, our preference is to go on the path of flexible coupling or Victolic coupling system. And the best part of the coupling system is like you just bring your two assemblies together. You put a flange on it and just do the screw and piping, which is one of the component of the flexible coupling. So by saying that, welding can be done also, but our preference would be always to go on the path of a flexible coupling, and one of the product of flexible coupling is a Victolic coupling. So that is related with the piping side of the thing. When it comes to the ducting is very easy. You just need to bring one module, you place the module onto the top of the other module, and then it's all about the bolting and butt joint or strap joints there. So you just bolt into it and the system is start operational after that. So I hope I answer your question well. Okay.
Okay, thank you. The second question is from Rizwan Mirza. Is your technical hitch okay now or still it's
Hello, am I audible now?
Yes,
Yes.
you can.
Okay.
Would you read the question or I should read the question?
Yeah, I would. I would. The second question is about an example of this technology in Pakistan. If he can narrate an application in Pakistan. This is Nabil Ahmad.
Sure. Nabil, when you ask example, it's not very specific what you're asking, but if you're talking about have you utilized BIM processes in Pakistan in construction project? Yes, we have done. We are working with some of our clients where we have done even up till LOD 300 level modeling with the client. And in fact, we also train our client team so that they can also do the modeling. When it comes to the modular construction, frankly speaking, in Pakistan, we have not reached to the level. In fact, one of the project, our plan was to do it, but then because of certain reason, things are not going into that direction. But if we have an opportunity, we will definitely go and embark onto that project on that. But definitely in overseas industry, lot of example, lot of data center we have done modular construction, a lot of office building we have done, even 21-story office building. Some of the pictures I have used in my screen. It was done with collaboration with a contractor team or builder team, and we were the designer of that project. It was done in off-site construction, and a lot of a lot of data I have utilized for those projects into my presentation. Obviously, I can't tell exactly the type or the name of the project because of the confidentiality what we have signed it up, but pictures I have shown, and I have kept everything anonymous. Pakistan is on the path, and I foresee some of the organization definitely gonna go there. Like we have been engaged for one of the project where the construction is happening in a very remote area, and our plan is to do full LOD 350 level modeling for that project, and keeping in terms of modular construction. All the components are going to get manufactured either in Islamabad or in Rawalpindi, including the ductwork, including the riser. And on site, it will be only and only installation work. Okay, but we are in discussion right now. It's not been awarded yet, but we are hoping that if it gets awarded, that will be a good example for us for the Pakistan market.
Okay. Now there is a question by Mr. Ijaz Ali, he's a civil engineer. The question is a bit blurred, but I'll try to rephrase it. He's trying to ask about labor wastages through labor sitting idle. Maybe preparation of histograms of various trades of labor, and then trying to make those histograms even could be an answer. I don't know really. It's a question to you.
Sure. Look, yes, we see it as can be done, but everybody has to come on board. The dynamics of Pakistani projects, they are a little bit different as compared to the first world country. My observation about the design practices in first world country versus Pakistan is like there the developer or the builder, they take their sweet time in terms of finalizing the design. So they go into design, they do all the coordination, everything, and when everything is fully coordinated, then they start the construction. And in that time, we have seen that very less labor idle time observed onto the project. The dynamics of Pakistani construction industry, what we have noted is a bit different. Here, generally, what we have noted, and by the way, not disrespecting anyone, but I'm just sharing my experience. Like we have noted in most of the projects, the whole idea is to bring the slab above the ground floor. That's the most important thing, whether even if the design is done or not. And those kind of the things are non-existent in first world country. But if we have a client who's on board, who understand what are the benefits of going on the path of BIM, and if we have a contractor or a builder who's on board of following, utilizing this thing, and if you have a designer on board to follow this path, I can confidently say that the owner or the developer, they can save easily 30 to 35% of the total cost confidently. Okay, and that is just a ballpark number figure I'm talking about. It is just giving more time to the designer to make the right decision for them. And my suggestion to everyone is, instead of becoming designer by themselves, let the designer do their job. And I would confidently say that if you follow this path, they can save easily 30 to 35% in terms of overall project cost. And this number can go higher. Okay, so I hope I answered your question.
Yes, I think this is more than adequate for the question. We have a comment from Malta, which is a compliment. In fact, he says that this is Shakil Anjum, that it was a great opportunity to learn. And there is Faiza Khalid, who says that there are a lot of doctoral opportunities abroad about digital twins. And she asks what kind of data is required to create a DT of existing buildings.
Correct.
DT, digital DT.
DT is digital twin.
Sure. Okay. First of all, thanks for the compliments from Malta. I think Shakil Anjum was the name. Okay, really appreciate you joining from overseas. And answering to the what type of data is required for the digital twin, it's all about the monitoring data is required for the digital twin. Smart building management system, smart energy management system, integrating with the local server or with the cloud. Nowadays, there are a lot of clouds services available. Amazon is one of them, Google is one of them. A lot of suppliers, they are offering this kind of thing. It's all about following the designer recommendation to connect your operational side of the thing onto the cloud, utilizing digital twin like a predictive twin or informative twin technologies, and segregate your data and link that data with the design inputs. Look, for digital twin, BIM is not the prerequisite. You can go on the path of a digital twin, okay? Only thing is, it will make a lot of sense to do the analysis if you have a designer input via BIM and you have the actual real-time data available from the building management system and energy management system. And once you have both information, you can interlink it together. But if you don't have, like if you are talking about an existing building, which has been there for the last 15 years or 10 years, one of the requirement is that we need to have a smart building management system. We as an organization, we are doing one project in Sri Lanka, and the building management system is great, but it's not being set up in the way we can extract all the value. So we are supporting the client. One of my partner, he is supporting the client in terms of coming up what is the right things to be done in the building management system, so that it can start spitting the data which is required for the digital thing, and in terms of doing the analysis. So it's all about the data. And once you have the data for the MEP system, then you can do a lot of miracles in terms of optimization side of the things, and in terms of giving the real value to the client of their money. Thank you.
I wonder if there are any more questions.
There are no questions on the Facebook as well as in the chat box. So I think, Rizwan, we should now, it's almost 2 hours now. We are approaching. So I think I have to make some announcements also, then we conclude it. Otherwise, we get some issues with the recording. And if it's okay with you, if you want to make any comment or last comment, closing comment, please make it. And then I'll make the final announcements.
Yeah, I would just say that it was an eye-opener, a wonderful lecture about an emerging subject. And I think everybody should get geared up for the future that is imminent now. Thank you very much, really. That's all, Tahir.
Okay.
Thank you so much, Rizwan sir, giving me this opportunity.
Khurram, Rizwan has already praised your lecture so much. So I would also say it was a marvelous lecture, and I really learned a lot from what you have delivered. So thank you very much, and I hope next time again, when we will give you the opportunity, you will come and deliver the lecture. Now it's like this, that the next lecture would be on the 11th November 23, same time, 2 p.m. Park Standard Time. And the topic is Future of Civil Engineering. And our guest speaker would be Dr. Taranjeet Singh Butalia. As you know, he has been delivering lecture already on our from our platform. I think this would be his second or third lecture. Dr. Taranjeet Singh Butalia on 11th November, 2 p.m. Park time, and the topic would be future of civil engineering. Now, Khurram, inshallah, your shield and your certificates will be sent by courier mail by our coordinating officer, Sadia Naveed, and the address which you have given to her, your shield and certificates would reach at your destination, inshallah, soon. And certificates of the participants can be collected from 19th October, that is Thursday, from our office 14A1 Block P, Model Town Extension, Lahore. Cell number before coming, if anybody wants to check, is 0347 462 5111. And I'll repeat it, 0347 462 5111. Contact person is Ahmed Akram. So again, I mean, the working days are from Monday to Thursday. 19th October onwards, you can collect the certificates. Now, today's program has been concluded. In the end, again, I will thank Khurram Tahir from the depth of my heart that he's came to our platform and delivered such a marvelous lecture, informative lecture. Thank you again. And ladies and gentlemen, thank you for your attendance. And thanks to my IT team who really worked hard to make this transmission smooth, both on Facebook and on Zoom. And all the participants who came on Facebook, sorry, I should have thanked them earlier. I'm thankful to Mr. Anjum and Faiza Khalid that they asked questions also on the Facebook. And thank you very much for supporting Pakistan Society of Civil Engineers. Allah Hafiz. God bless you.
Thank you so much.